Hi, John here. Today we're going to look at natural draft, forced draft, induced draft and balanced draft. And I'm going to explain to you guys and girls exactly what we mean when we're talking about those terms. So let's dive straight in and we can look at first natural draft. We can see here a natural draft cooling tower. I'm not going to go into detail, I'm just going to show you how it works. What's going to happen inside this cooling tower is the air is going to pass in through the lower sections here, and then it's going to pass through a heat exchanger, which is this black area, and then it's going to pass up through the tower. Now, the thing that's causing this movement of air is actually just a temperature difference. The water comes out of spray nozzles, that's these blue items here, and as the water comes out, it's going to heat up the air in the tower in this section, or specifically within the black section here, the heat exchanger. As the air gets hotter, its density is going to decrease. That means it's going to rise up above the ambient air, which is cooler. So because the air is less dense, it is now going to rise up and out of the tower. And as it rises up and out of the tower, it's going to draw cooler air in through the base. And this process continues and continues, and that we refer to as natural draft. It's actually what we refer to as the stack effect. So that's natural draft. Let's go and have a look now at forced draft. You can see on the screen now we've got two separate cooling cells. I'll just do a little spin so you can have a look. And the one at the front here is a forced draft cooling cell. Take a cross section. If we have a look here, maybe I can start the animation as well. We can see there's arrows coming in here. They'd actually be going in these two holes, and then the arrows come back out the two holes at the opposite end here. And we can also see that the arrows are running inside these pipes and along. So this is a heat exchanger, similar to a shell and tube type heat exchanger. If I just pause that for a moment, I'll take the cross section again. So the fluid is coming in, it's coming in the pipe here, it passes through these tubes and then goes out. That's a standard sort of heat exchanger arrangement, and we've got a forced draft setup. What that means is the fan is placed before the heat exchanger, and then we'll force air across the heat exchanger. That's a forced draft setup, or mechanical forced draft setup. The mechanical simply refers to the motor and the fan which you're using to force the air across the heat exchanger. So unlike natural draft, we've actually got some components here, some items of machinery that are causing the air to flow across the heat exchanger. Now let's go and have a look on the other side, and we can look at an induced draft cooling cell or cooling tower. Again, the same setup, the liquid is coming in here, travels through, and when it exits, it's going to be cooler because it's being cooled down by the air. The difference here is the fan is on the upper side of the heat exchanger. It's inducing a draft, which means the air is passing over the heat exchanger before it passes over or through the fan. So that's induced draft. And induced draft means we're passing over the heat exchanger first and then across the fan. Now it might not always be a heat exchanger, it might be something else, such as a boiler. So maybe we're using a fan, we call this a primary air fan, to push air into the boiler, and we'll use that air for combustion. And then maybe we'll use an induced draft fan, typically called an ID fan, and then we'll draw the exhaust gases out of the boiler. So different applications for forced and induced draft fans. And that brings us on now to our final type of draft, and that is balanced draft. Balanced draft simply means that you're supplying air into a space, let's imagine a boiler, and you're drawing the same volume of air back out again on the opposite side. So we can see on the diagram here there's a fan or a primary fan supplying air to a boiler for combustion. Now we don't want the exhaust gas hanging around inside the boiler because you can't burn the oxygen twice. The oxygen's been depleted, that's why it's exhaust gas. So we need to get rid of that exhaust gas as quickly as possible. In order to do that, we use what's called an ID fan or induced draft fan, and will suck the exhaust gas out of the boiler. Now with one fan blowing into the boiler and one fan sucking exhaust gas out of the boiler, we're actually going to have a balanced draft. Sometimes they'll call this suction firing. And that is the 4 main types of draft that you're going to come into contact with. So natural draft, forced draft, induced draft, and balanced draft. Hope you find that informative and interesting. If you've got any questions or comments, please let me know. Thanks very much for your time.